Hello, today I will be solving question 2 in the unit of geometric vectors. So the question is asking us, suppose ABCD is a square. State one vector that is equal to, and we're going to have numerous questions. There's two ways to solve these equations, algebraically, and we can also solve them visually with the ABCD square that I've drawn over here. This square is going to help us to understand what is actually happening to these vectors with these arrows that I've made. So let's take a look at our first equation. So let's call our first equation I. So vector AC plus vector CB. So at first glance, we can see that there are two common terms, C and C. While we look at that our visual representation, we can actually see what is actually happening to these vectors. By using the tip to tail principle, we can use an arrow AC. I'll use a longer arrow right here. So AC and CB, since it's tip to tail, we can say that that equals vector AB. So the red is what the vector equals. However, by looking at this algebraically, we can solve using like terms, because sometimes you might not always have a visual representation. I'm going to write this in red here. So C and C are the like terms, and we can simply cancel them out, resulting in our answer of AC vector plus CB vector equaling AB vector. So that's just our first equation. Just note here, so when you're looking at it, remember to cancel out like terms. So let's move on to our second question. Our second question is going to be dealing with subtraction now between two vectors. So vector AB minus vector DA. So we need to understand before we do anything what a minus vector actually means. So let's look at our visual representation on the square that we have made. So vector DA is negative, so DA, which actually means that it's just a negative version of a positive. So it could, negative DA could also equal positive AD, which is also equal to positive BC. So let's come back to our algebraic equation. With the new knowledge that we have, we can say that we can rewrite this to vector AB plus vector BC, because now we have two like terms, B and B. We can do what we did in the first question and cancel out these like terms. And that will equal vector AC. So just a little note to what happened here. A negative is opposite. So for example, we had negative dA is also equal to positive AD, which is also equal to positive vector BC. And we could have used this vector, however, we went to BC so we could have the like terms of B and cancel out and get our final vector. Let's go to our second last question. So the question is vector AB plus vector CD. Okay. So let's look at our visual representation. So we have vector AB plus CD, but we need to find like terms. So let's look at CD. CD is right here. What else could we say that CD is equal to? We could say that CD is equivalent to vector BA. That would work because our first vector is AB plus, and then we could say BA, and we would have like terms of B. So let's look at our So we now know here that vector CD also equals vector BA. So let's rewrite that. Vector AB plus the new vector that we found, vector BA. We use the rules that we found in our first question to cancel out the like terms. And we now have vector AA. But wait a minute, we can now have this vector because this basically means that the vector starts and stops at the same point. So this actually equals vector 0 because it starts and stops at the same point. So just note here certain vectors are equivalent. So we found here that vector CD is equivalent to vector BA. And also here, since we have a vector with two of the same terms, two like terms starts and stops at same point, equaling 0. So we're going to move on to our last and final question, where we're going to combine everything that we've learned so far. Let me just clean that up. Okay. Okay, it's not drying. Okay, so vector AB plus vector AC plus vector AD. Okay, so at first glance now we don't have any like terms. However, it doesn't mean we cannot rearrange or try to find equivalent terms. So let's look at AD, for example. Look at our visual representation. So what is equivalent to AD? We could say that BC is equivalent. So let's look at our algebraic. Do we have any B's in the second terms that can match up with the first term of BC? Yes, we do. So we have our vector AB from here. This is now BC. We can still just put it right there so we can cancel out the like terms. So we could say plus BC. And then we could just have our other term AC right there. So we find the like terms, we cancel them out, resulting in vector equals AC, which is our new vector, plus we have another AC here, AC, which we could simplify it as just 2 AC. Okay, so we used everything we've learned. We used the visual representation. We rearranged. We found equivalent terms. We simplified, and we got our answer. Hope you found this helpful, and thank you.